Determine whether the series is convergent or divergent. So we got a series of n plus 1 times 3 raised to n all over 2 raised to n cube. So a lot of terms, and this is not something raised to n. If we had something raised to n, then we would use the root test. Here we use the ratio test. Okay, ratio test. an plus 1 over an absolute value, and we take its limit. Okay, this is an nth term. An plus 1 is the next term, means n is n plus 1. This n is n plus 1. Okay, so let's take this limit. And absolute value is not needed in this question because everything is positive. N is going from 1 through infinity, so absolute value is not needed because absolute value of this is itself. So an plus 1, so the next term would be n is n plus 1 plus 1, so n plus 2 times 3 raised to n, now n is n plus 1, to n plus 1 raised to n plus 1, n cube means n plus 1 cube. So this is an plus 1th term divided by an is itself here. So n plus 1, 3 raised to n over 2 raised to n cube. Now we want to take its limit when n goes to infinity. So let me change this division into multiplication. So we need to flip this. And here is n plus 2. At the same time, 3 raised to n plus 1 can be factored because I see 3 raised to n here. 3 raised to n plus 1 is 3 raised to n times 3 raised to 1, or just 3. Okay. So this is 3 raised to n times 3 over, in the same way, 2 raised to n plus 1 is 2 raised to n times 2, and we got n plus 1 cubed. So we cannot separate here though. This division into multiplication, flip this fraction, flip. So 2 raised to n cube on the top, n plus 1, 3 raised to n on the bottom. Now there are some cancellations. Okay, and that leaves this fraction as, here is 3 and 2 on the bottom. These are constant. 3 halves we can pull all the way out if we like. Okay, 3 halves. And about n, so n plus 2 times n cube over n plus 1 cube n plus 1. Oh, n plus 1 cubed, and we got n plus 1, so n plus 1 to the 4th, because it's the same thing. 3 copies times 1 copy, so 4th copies. Okay, let's compute this limit. This constant we can pull outside if we like. So this limit, let's look at carefully. We can in fact distribute. So this is pretty much n cubed times n is n to the 4th plus n cubed times 2 is just 2n cubed. That's on the top. On the bottom, n plus 1 to the 4th means if we multiply n plus 1 4 times, n plus 1, n plus 1. Okay, we can multiply these two, then multiply. And as you can see, the very first term would be n to the 4th and other terms. Because this limit, when n goes to infinity, only the leading terms matter. So I can just write in this way. So this limit is in fact 3/2 times, look at the leading terms on the top and bottom, n to the fourth, 1 over 1. So the limit is just 1. Okay, that means the limit is 3/2 times 1, just 3/2. So we found the limit of this ratio test. That is 3/2 in this case, which is bigger than 1. And when this limit is bigger than 1, the corresponding series diverges. So this implies the given series diverges.